Just doing a couple little checks here. And then we are good to go. All right. So the first thing that I want to talk about is a lot of times when you're using coding agents, AI coding agents, you don't get very deterministic behavior. Of course, if you use some of the larger models, Opus 4.5, Codex 5.2, and the higher reasoning levels, you get more predictable behavior. But one of the things that I wanted to demonstrate is that you can use meta prompting in such a way to get more deterministic behavior from these tools, especially smaller
Claude
models.
Code needs your attention.
Oh, there it goes. I'm going to demonstrate that right now with a couple different smaller models. In this particular instance, I'm going to use Haiku 3.5. I'm sorry, not 3.5, 4.5 without thinking, and show you how I got it to work basically deterministically. I'm going to automate a certain part of my Mac by resizing a window. Let me demonstrate that right now. Resize the Warp app window to 9:16 ratio. I was going to go ahead and run some scripts here using
Main Claude
OSA
Code finished.
script, which is basically a way to run Apple script code through the command line. As you can see here, this is a ratio of 9:16. Look at that perfectly line up. And how I got to this point was through a lot of iteration and prompting Claude Code through its own errors and asking it what did it learn from its own errors, and then saving those learnings to Claude code. I'm sorry, to Claude.md. Something happened in the background. Now, let me show you what that process looks like when you are starting from scratch. You don't have anything in your Claude MD, no instructions that are helping guide the model. In this particular instance, you see there is no Claude MD file here. And so I'm going to start from scratch. And because the non-deterministic behavior of models, sometimes the model trips up over and over and over on this particular problem. So I turned off thinking for haiku here. You notice that. And then I'm going to ask it to do that resize again. But in this particular instance, there are no system instructions or instructions that are being appended to the beginning of the conversation through the Claude MD file. Resize the warp app window to 9:16 ratio. Now I'm going to add a little bit more information because Claude does not know where I'm going with this. So I'm going to say, use the OSA script with your bash tool only. And I'm going to let that go ahead and issue that. So you see how it's tripping up a lot of times right now over and over on these errors. Because
Claude code needs your attention.
It's starting from scratch. It doesn't know enough to execute what I want it to do. And now it's pretty much going to brute force this and try to figure out how to resize the window. And because it's a smaller brained
main Claude code finished
model, it's not Opus 4.5, is not going to think as much and it's going to trip up a lot. So we see that it right here, it actually resized it, but it didn't really resize it to 9:16 aspect ratio. So now I'm going to prompt it to go ahead and introspect a little bit to see what it can do in order to get to that final destination of being able to resize this appropriately. So I'm going to guide it a little bit. It is not in the correct aspect ratio. Debug why. Use atom of thought. And my speech-to-text app keeps saying, typing atom instead of atom. They sound about the same. To break down the problem. So atom of thought. Atom of thought is a way of prompting that came up last year, and it started to become popular. Basically,
Claude
it's
code
just
needs your attention.
breaking down things into the smallest possible unit and then giving it a plan. So I'm nudging it in that direction and then I'm going to see if it can actually perform what I want it to perform. So in this case, this seems like a much better aspect ratio. And we're going to let it execute that. What I'm going to do here is, instead of it, you see how it keeps on asking me to
Claude Code needs your attention.
approve this command. Well, this is, and I already have this, and I'm going to show you here. I already have this approved as a command in my settings, but it keeps on prompting to in order for me to approve that. And if you notice a little bit, there's something particular about the way that this command is being executed. So what I'm going to do is I'm going to have it do execute in a different way. Use the E flag. Let's try this again. When calling OASA script, use the E flag or E option. Okay, now you see that it's actually pre-approving those commands.
Main Claude Code finished.
Okay. So we're going to see, did this line up in the way that we expected it to? So I'm going to bring up the guides to here to demonstrate, 9:16 ratio. It got it close. It didn't get it completely. But I'm going to show you just this process of how we got to this point. So I'm going to ask it, what did you learn from your failures? Now we're going to change it a little bit. You learn about what actually worked. I'm using some meta prompting to understand
Main Claude Code
why
finished.
that actually behaved the way that it did. So let me remove this here. It's just a little bit easier to read this. So it says system events and whatnot. What I actually wanted to meta prompt is on what do you learn about resizing that actually worked versus what didn't. So this is where the meta prompting comes in. And we're going to
Main Claude Code finished.
recursively self-improve the instructions that are in the Claude MD over and over and over to the point where it's almost deterministic. Okay. So what worked here? This is not telling me exactly. Lessons learned from actually getting in the right ratio. So what we're going to do here is we're going to have it resize again, get more information into the context window, and see if it fails.
Main
Okay.
Claude code finished.
So this looks pretty good. Now what I'm going to say. What did you learn about resizing that actually worked?
Main Claude code finished.
Okay, so here's a couple lessons. Tell application, tell process warp, successfully manipulated the window while tell application warp failed. So a little bit difference in how it was called, right? And then also the E flag, because we already know that that one's already pre-approved. And now I'm going to say that I wanted to persist those learnings into Claude.md. Make these instructions more concise and strip it down to the bare bones of what you learned that actually worked for resizing.
Main Claude code finished.
Okay. And since I don't want this to be stuck to a particular size, I'm going to remove that part of the prompt. Remove the explicit pixels of 1271.
Main
To those
Claude
of you
code finished.
that have joined, hello and thank you for watching. If you have any questions, please participate. I'm actually looking at the chat window here. Okay. Now here's the part where we persist these instructions to Claude. Persist these instructions to Claude.md. Now it's going to, that information that extrapolated those learnings that it learned from its failures were meta prompting to save those into Claude.md.
Claude code needs your attention.
Rename it. Just prompt it to rename it the correct way. Okay, save.
Main Claude code finished.
All right, so let's start with the fresh session here. Instead of doing new, I just can't remember if Claude automatically reloads Claude.md. file in the same session, so I just killed that session and started a new one. So I'm going to do the resize again. Resize the warp app window to 9:16 ratio. And at this point, some of the places where it was tripping up, thanks to the meta prompting, it should reduce those failures. Okay, so this does
Main
look
Claude
like
code finished.
the correct ratio. But you notice here that it's a lot tinier than it could be. So now this is where the recursive self-improvement part comes in. We're going to be improving the instructions over and over and reducing the edge cases over time. So right here now we're going to say, I want you to use all the available space that I have in my display. Resize again. Okay.
Main Claude code finished.
So as you can see right there, now that's what we're looking for. And that looks perfect. You can see how that lines up with the guides here. So now the same thing that we did the last time. What did you learn about resizing? But what's different, or I'm going to say in this session, that's not already in then reference claude.md. I'm having it look at its own instructions and then looking at the differences about what actually worked so that it can improve those instructions. Okay. So now it says based on this session specific height limit value is capped at the width is truly flexible, silent capping behavior. The height limit is enforced silently. Okay. The resize command succeeds without error. What I'm going to have it here do is removing specific values. What have you learned in this session that helped resize to the correct ratio using the available space? So I wanted to generalize these instructions. That's important because you don't want to get stuck to one specific scenario. You want to generalize so many different scenarios. You want it to be able to behave deterministically, but not in the wrong way. You don't want it to be stuck to a very specific width or to a very specific height, because that's not exactly what you might want. You want it to be flexible. Okay, so now I'm going to double check here to make sure that this is actually correct here. What I learned is use the available space, query the display dimensions first. That sounds, yes, correct. Calculate the constrained dimension. Once I knew that, I could calculate which dimension would be limiting factor. That sounds very, Very correct. And the workflow approach
Claude
is
code
get
needs your attention.
display dimensions, calculate the maximum size that fits the ratio within those bounds, resize using system events, verify the actual results. This sounds accurate. So what I'm going to do now is to persist those to Claude again. Persist what you learned in, and then reference Claude. Okay, so maximizing space with aspect ratio, querying, and all the whole workflow.
Claude code needs your attention. Main Claude code finished.
Okay, so once again, now we're going to, we have used meta prompting to go ahead and do the self-recursive improvement there. And now we're going to see how it behaves with these new instructions that have gone through 2 rounds of improvements. Let's go ahead and change the dimensions here. And all the way to the bottom. Resize the warp app window to 9:16 ratio. So now let's see if this gets it on one shot, in one shot. Based on these improvements that we have done over time. And if we go back here and
Main
check,
Claude code
I'm going to bring
finished.
this over to the center. Bring up our guides, and will you look at that? Now, just to test this one more time. Okay, it's going to resize this just to see if it's deterministic enough. Resize the warp app window to 9:16 ratio. It should be pulling in those up-to-date Claude instructions. And we see right here that it struggled again. Wow. Okay. Let's see what it did this time. Okay.
Main Claude code finished.
Now that did not behave as expected. Okay. And now we're going to just prompt it again. Use that meta prompting to understand what happened. So I'm going to put it just about here. That did not behave as expected. It created the window and made it resized the window in such a way that made it very small. Resize again to correct 9:16 ratio using the available space. So let's see if it gets it this time. My intention here is that if it gets it this time, I want it to learn from its own behaviors. It's going to look at the display resolution here. And here, it seems like it really did get it this time. It didn't get the full height, but in terms of the aspect ratio, should have gotten it right here. This looks about right. So what I'm going to do here is I'm going to drag it to the top. Got to be careful with this Mac OS behavior where you drag it to the top and it maximizes the window. Resize again to 9:16 ratio. And this is all, we're getting it to go and learn from its mistakes.
Main Claude code finished.
This requires beating it over and over multiple times until it's learned enough times to behave more deterministically. Just as you learn from life. You make mistakes and then you learn from those mistakes. I'm going to correct it here again. This is not the correct ratio. (9:16), and I'm going to push it in a very specific way by, again, using atom of thought. I'm intentionally not using plan mode. This is just pure prompting and prompt engineering here. Now let's see if it can get that by using this prompting technique, atom of thought. Like I said before, we're going to try to get it to learn from its own mistakes.
Main Claude code finished.
Okay. And this looks about the correct ratio. It's not using the available space. So I'm going to try to get it to use available space here. That looks like the correct ratio. Use the available space though. Use atom of thought to break down the problem. And boy, see if we can get correct spellings. I'm going to say atom of thought here.
Main Claude code finished.
As you can see, that looks a whole lot closer than it did before. We're going to prompt it. We're almost there. That almost looks perfect, but the width just looks slightly skinnier than it should be. We see that's, I don't know, 10 pixels thinner than it should be. Okay. Use atom of thought. There we go. To break down this problem. Make sure it's in 9:16 ratio. And using the available space. Like I mentioned before, we are learning through mistakes, and we see that, it makes some mistakes and then it gets better, then it makes more mistakes. Once I get it to a point here that it's like, yeah, that's exactly where it should be, that is when I persist it to the CloudMD file. I don't persist it until we get to that point. So it's trying a couple things, it resized it, and noticed it wasn't the right ratio, and then I resized it again. You saw how it's going back and forth, and trying a couple different things. Let's see if it gets it. Okay, this might be it.
Main Claude code finished.
This might be it right here. Okay, it seems like that's not exactly perfect, but let's do the math on this. Okay, so we should have, I believe it's 715 times, let me see if I got this right, divided by 9. Okay, so it does seem, yes, that maybe my guides are off. I did the math on this.
Claude code needs your attention.
715 times 16 divided by 9 gets roughly 1,271 pixels. So this is actually correct. What did you learn new that's not already in? So first I'm going to say, yes, you got the calculation correct. I was wrong. What did you learn new that's not already in Claude code? We're doing the self-recursive improvement. This is what makes it more agentic. Now,
Main
if
Claude code finished.
we had this automatically learning, then basically you have an agentic tool that's learning from its own mistakes, but we don't have it automatic. I haven't tried that out. I don't trust it to get to that point yet. I am involved in the process through human in the loop. Okay, let's see, based on these discoveries here, if this actually looks accurate or not, because sometimes what it says is just, it's like completely off. So I make sure. And just remember, this is haiku at its lowest reasoning. No reasoning at all is the smallest model. And it's not going to think on its own unless you use prompting through prompt engineering techniques. So new information, specific hard limits. I don't want those hard limits. With constraint is absolute, not flexible. States width is flexible, but I discovered
Claude
width
Code
has a
needs your
hard
attention.
cap. It might have a hard cap because of the display itself. And height limit is independent of width. The severity is always capped at 1271. Okay, this is the part where I don't want specific hard-coded values in the CloudMD. I want it to generalize these what it learned. Generalize what you learned based on contexts such as available space, which is dependent on the display. Execute any additional code to verify that. Let's see what it comes up with right now. And
Claude Code needs your attention.
it might have actually, can you believe that? Ignored part of the Claude instructions. I'm gonna let this go though. And system profiler, get the resolution and whatnot.
Claude Code needs your attention.
See if he could pinpoint this. Okay, so it moved it to the incorrect window. This is probably at a point where
Main Claude Code finished.
I'm really pushing Haiku to its absolute limit. But let me see what it comes up here. Okay, display 1, external, display 2. I believe display 1 displays is this one. And based off the resolution, I can't actually say that it's my Retina display, but it could be my external monitor. I can't remember the dimensions here. But let's look at these generalizations that were made here. Generalized learning. Warp's window limits appear to be display dependent. Okay, so height here. This accounts for the Mac OS menu bar. Sounds pretty accurate. This leaves space for a system element. Or is deliberate warp constraint limits change per display? Yes. So the formula to calculate max window size for any display would be max height is a screen height minus 25 pixels.
Claude Code needs your attention.
The top. Let me see what my stream health looks like. I'm hoping it looks poor right now. Hoping that straightens out. Let's see if it does. Let's get back to here. So the formula to calculate max window size for any display would be max height equals screen height minus 25 pixels. Screen width times 0.66 approximately is the width. I'm not so sure about this assumption here. Okay, that doesn't sound convincing to me. So what I'm going to do here is I'm going to roll back one message here and see if it learns anything new. Just remember, I'm not using any reasoning, and this is on purpose. I'm pushing the limits on this model. Use O script E option moving forward. Starting to get exhausted here.
Main Claude Code finished.
Warp width, key inside the height constraint is almost full available height, missing only 25 pixels, but width is capped at only 30% of available space. I don't want this to be completely pinned to a percentage. So let's see here what we can do. Scales with display. Okay, I want you. Oops. I do not want you to pin this to specific hard-coded values, but to pull those values dynamically based on what you're getting from the display instructions. I'm going to say dimensions. Execute OSA script commands. use atom of thought to break this down. What I'm trying to achieve is that I wanted to get the full height Okay, I got the full height there, but it's still not the ratio that I want. Still not the ratio that I want. Now I went back to not the ratio. And that's the ratio that I want right there. Okay.
Main Claude code finished.
So did a couple different variations, and if you see that, it was resizing my windows, and it automated that, and it checked. It was like, okay, let me try it here. Well, that's too wide. Let me try it here. Whoa, that's too small. And at this point, it got it correct. So let me see, based on what it learned here, if this is more a generalized algorithm. Here, dynamic warp resize, aggregate query, display dimensions dynamically. Okay. Constraint request to warp to actually get actual dimensions returned for any desired ratio. Do that calculation, resize to that ratio. This works on any display. Okay, so this seems like a lot more
Claude code needs your attention.
what I want. What do you learn about this session that, first of all, I'm going to say here and look at the, bring this over. Yep, this looks a lot better. This looks, this is, no, not looks. This is exactly what I was looking for. So what did you learn about this session on resizing that's not already in Claude MD? So this is the part where I'm going to persist. What it learned using self-recursion improvements. We're using that meta prop thing in there to prompt itself to
Main Claude
improve
code finished.
its own prompt. Okay, let's see if this is better. New learning's not in. Just says height is capped. I discovered with this display, these versions appear consistent resize attempts. Discovered how did it discover those constraints? So it went through this process. It discovered that if it requested these, it forced to reveal its caps, okay? Width is not flexible. It was just it's constrained just at a different
Claude
ratio
code
than
needs
height.
your attention.
Okay. So what I'm going to do here, I want you to make this more concise. And not reference the hard-coded percentage values that you described. Let's see if this looks a little bit better.
Main Claude code finished.
constraint discovery method. No need for hard-coded values with this constraint too. What is hard limited? Okay. So now this is the part where I wanted to persist those to CloudMD, improve its own instructions. We went through 2 rounds. This is going to be the 3rd round. Persist to CloudMD. These new learnings. And before I actually accept what it says to me, I'm going to check what it says here. Dynamic constraint discovery to find
Claude
warp's
code needs
actual
your
limits.
attention.
And then it does request that both dimensions are constrained with it's not truly flexible. Calculate restraints, divide actual. Then it does the asking to do the formula here. Apply the aspect ratio formula here. Independent constraints. Height limits are separate. Respond to the. Okay. So that looks about right.
Main Claude code finished.
And just to show you, this is a whole process of just going through this, prompting the model, and we went through a pretty brutal way of like getting the model to fail over and over and over and over until it actually did what we wanted it to, and then persist what it learned into its own. I'm not going to say system instructions because it's a little bit pedantic about how CloudMD is applied in Claude code. But we're going to persist those instructions to an area, the CloudMD file, which will be used to make the behavior a lot more deterministic, a lot more predictable.
Claude code needs your attention.
I'm gonna kill the window here. And let's see if we can one-shot. This is the 3rd round of using meta prompting. Third round of improving the CloudMD to see if it works as expected. Resize the warp app window to 9:16 ratio. Let's see. Oops. I didn't even start. Let's start Claude right here. Restart the warp app window to 9:16 ratio. Resize. And if everything works as we expect it to, which it might not, but we're going to try it anyways, this should get us to the 9:16 ratio based on what it learned. Everything that it learned
Main
over
Claude
these
code
3
finished.
different rounds of improving its own instructions through meta prompting. So as you can see here, we got it to work on the first try. And there you go. This is exactly how you can improve through meta prompting, asking the model what it learned from its own failures and what it learned from its own successes, and persisting those learnings, those insights to an area where it's going to read those instructions again. For Claude Code is going to be Claude MD, but for others like Codex is going to be agents.md. For Gemini is going to be Gemini.md. And for any agent that you're going to be using that's supposed to improve on itself, this is specific to the ones that have human in the loop. You can use this process. So I hope that you learned something out of this. I've been finding a lot of good use. It was into me like, oh man, especially how Ralph Wiggum loop has been getting very popular on X and on YouTube. This is the manual human in the loop way of, wow, Ralph Wiggum. You are the Ralph Wiggum. You're the one
Claude Code
going
needs your attention
and asking the agent to do the same thing over and over and over. But in this case, you are asking to learn from its own failures. So use these techniques with meta prompting, and for smaller models, such as what I showed you here with Haiku 4.5 and no thinking enabled